Hello everyone. For my project, I created a humidity management system which can be used in a variety of medical applications. As we know, it's critical to maintain humidity within a specific set point or range for many medical devices. For example, controlling and monitoring humidity in neonatal incubator systems or in ventilator flow tubes. For my experimental setup, I have three main hardware components consisting of my digital relative humidity and temperature sensor, the Nucleo microcontroller, and a special purchased Arduino part called the Grove Atomizer, which is a DIY humidifier. The Grove Atomizer is basically made up of two components, a driver board seen in blue and an atomizer, which is essentially a piezoelectric transducer, which is seen in white. When placed in water, the transducer produces high-frequency vibrations, which create waves in the liquid film. Once the waves reach a certain critical amplitude, they become too tall to support themselves and just fall off as tiny droplets, which we observe as water vapor. Since humidity is a measure of water content in air, the produced water vapor changes the humidity environment. So before I built a control system, I just wanted to test the function of my digital relative humidity sensor at room temperature in my office. And so when we look at the serial output from CoolTerm, we can see that we're getting a temperature of 23 degrees Celsius and a relative humidity of 52% plus or minus 2%, which is very reasonable for an internal office environment. Okay, here I have my experimental setup with my microcontroller, the sensor, and my Grove Atomizer humidifier. So we have the transducer in this cup of water, which then produces the water vapor, which is producing higher humidity when on. So the driver board here requires a 5-volt input, which is what we have here. And this is connected to the 5-volt pin of the microcontroller, as well as the ground pin of the microcontroller. The sensor has a 1K pull-up resistor and a 100 nanofarad capacitor for wave filtering. The second pin, pin 2, is connected to D8 of the microcontroller. This is the signal input, digital input. And the enable controller is connected to pin D7 here with this yellow cable connected to the driver board. So how my system actually works is it first asks the user for a set point that you desire. So I entered 70 here for the demonstration. And so it'll take its first humidity and temperature reading. And the actual logic for the controller to turn off the humidifier, you can see it's on now, is actually based on the error calculation and not just purely whether it's above or below the set point. And so my system employs PID controller logic, which takes the error values from a proportional error calculation, an integral error calculation, and a differential error calculation, and summates them. And the logic is here basically when the cumulative error becomes negative, we turn off the humidifier. And so we can see that here it crossed over to the negative values, and it's sent to the enable 1-bit controller to turn off the humidifier. Now we can see in our measurements we're coming from the other side. The cumulative error is getting less negative, which means we're getting close to wanting to turn the humidity back on. So we can see that the humidity is overshot a little bit and below our 70% set point, but now we can see that the error value crossed over into the positive and we turn back on the system.